Hello students, welcome to today's lesson where we are going to look at temperature and thermometer. We start with the definition of temperature, where we say that temperature is the degree of hotness or coldness of a body on some chosen scale. It is measured using thermometer and its SI unit is Kelvin. We also have degrees Celsius, or what we call centigrade, that are also used in measuring temperatures. Temperature is a scalar quantity, which implies that it has only magnitude with no direction. Then we move to thermometers. A thermometer is used to measure temperature, and each thermometer is designed for a specific use. So we look at the first one. We have liquid in glass thermometer. This one, it has liquid in the bulb, and this liquid expands up the capillary tube when the bulb is heated. So we look at the common features of this thermometer. We have the bulb. Inside the bulb, we have the thermometric liquid. We have the glass stem. Then we have the capillary bore. And finally, we have thick glass wall. So what is the purpose of each feature? One, we have bulb. This one contains thermometric liquid. It is thin, and this ensures that it increases the sensitivity of that thermometer. That is, it will allow a quick transfer of heat. Then we have capillary ball. This one is narrower, and this ensures that it increases the accuracy of that instrument. So this is where now the liquid rises up or falls when the temperature changes. Then we have the glass stem. This one is made of thick glass, and this one strengthens the thermometer and protects the liquid that is inside. It also acts as a magnifying glass, so that now you can be able to get the reading accurately. Then we have thermometric liquids. These include mercury, alcohol, and oil. We look at the properties of a good thermometric liquid. One, they should not wet or stick on the glass. They should expand and contract uniformly. They should be a good conductor of heat. They should be feasible. They should have a high boiling point and a low freezing point. Then we need to look at the properties of water that make it not possible to use as a thermometric liquid. One, water wets the glass or it sticks on the glass. Then it has unusual expansion. It is a bad conductor of heat. It is infeasible, and it has a very high freezing point, that is at 0 degrees Celsius. Then we look at the comparison between mercury and alcohol as thermometric liquids. And this one is tabulated in our table below here. One, we have that mercury has a very high boiling point, that is at 357 degrees, while alcohol has a low boiling point, that is at 78 degrees Celsius. Then number two, we have that it has a relatively high melting point, that is mercury at negative 39 degrees Celsius, while alcohol has the melting point at negative 115 degrees Celsius. Then the third one, we have that mercury is a good thermoconductor, while alcohol is a poor thermoconductor. Mercury expands regularly, while alcohol has irregular expansion. Mercury do not wet the glass, while alcohol wets or sticks on the glass. Then mercury is opaque, and therefore it is visible, while alcohol is transparent, and if you have to use it, you have to color it so that it can be visible. From there we move to the reasons or the areas where you can use alcohol thermometer and where you can use mercury thermometer. Now, starting with the alcohol thermometer, this one is best for use in the cold conditions, and this is because it has a very low freezing point at negative 115 degrees Celsius. But if you have a high temperature, you cannot use this one because it has a relatively low boiling point, that is at 78 degrees Celsius. We have mercury thermometers. These ones are best for use in high temperatures. This is because they have high boiling point at 357 degrees Celsius. But if you have extremely low temperatures, you cannot use mercury thermometers because they have a high freezing point at negative 39 degrees Celsius. From there, we move to calibrating liquid in glass thermometer. We need to note the following. One, that a thermometer has two fixed points. One, we have the upper fixed point that is at 100 degrees Celsius and the lower fixed point that is at 0 degrees Celsius. Now, the upper fixed point is marked when you put the bulb of that thermometer in a stream of boiling water, and you should ensure that you are at standard atmospheric pressure. Then the lower fixed point is marked by putting the bulb of the thermometer in pure melting ice. Then the range, remember now you have marked the upper and the lower. The range between them is subdivided into equal divisions, and each division is given 1 degree Celsius. So therefore you will have the scale of your thermometer. From there we need to compare the Celsius or centigrade scale and Kelvin scale. Before we compare the differences, we have that in Celsius scale we have two fixed points, as we have mentioned. One at 0 degrees, that is lower, then the second one at upper degrees or at 100 degrees Celsius, that is the upper fixed point. Then for the Kelvin scale, it has the lower at 273 Kelvin for pure melting ice and 373 Kelvin for steam or pure boiling water, and this should be done at standard atmospheric pressure. Then we move to assignment. In this assignment, if you look, they are just the statement questions like define temperature and state its SI unit. These are the questions that you can get the answers from your notes, from your videos. So make sure that you comprehend, go through the questions. If you find that you have some problems, repeat or replay the video and make sure that you get the correct answers. So thank you, and let us meet in our next lesson.